Have you ever wondered how your heart, a small organ about the size of your fist, keeps you alive every moment of every day? Yes, this tiny powerhouse nestled within your chest is responsible for the vital role of supplying oxygen and nutrients to every cell in your body. Isn't that incredible? Let's take a closer look at this remarkable organ. The heart, in its simplest form, is a muscle. But it's not just any muscle. It's a specialized type of muscle called cardiac muscle, designed to work tirelessly without fatigue. Now imagine a house with 4 rooms. That's a simplified way to look at your heart. It has 4 chambers, 2 atria on the top and 2 ventricles on the bottom. These chambers work in perfect harmony, contracting and relaxing to pump blood throughout your body. But it's not just these chambers doing all the work. They're aided by 4 valves that control the flow of blood, ensuring it moves in the right direction. Think of these valves as traffic signals, letting blood flow through when it's time to go, and stopping it from flowing back when it's time to stop. The heart isn't just a pump though, it's a sophisticated piece of biological machinery that keeps every cell in your body nourished and alive. Each contraction sends a wave of blood rushing through your veins and arteries, delivering life-sustaining oxygen and nutrients to every corner of your body. And all this happens without you even having to think about it. Your heart beats about 100,000 times a day, pumping nearly 2,000 gallons of blood. That's enough to fill an Olympic-sized swimming pool in less than 50 days. The heart's ceaseless work is truly a marvel. But what makes the heart tick? How does it maintain a steady rhythm? Well, that's a story for another scene. So stay tuned as we delve deeper into the heart's rhythm, the electrical conduction system that controls it, and what happens when things go awry. The heart's rhythm, often taken for granted, is a complex and fascinating process. This rhythm is orchestrated by a series of electrical impulses, essentially the heart's own electrical system, keeping everything in sync. Just like a conductor guiding an orchestra, this electrical system controls the sequence and rate at which your heart contracts, ensuring blood is pumped efficiently throughout your body. Now imagine trying to see this rhythm. To visualize these invisible electrical signals, enter the electrocardiogram, or ECG, a tool that brings the heart's rhythm to life on a screen or paper. The ECG traces the heart's electrical activity, producing a waveform that depicts the timing and strength of these impulses. A normal ECG trace is a series of waves and complexes, the P wave, the QRS complex, and the T wave. Each of these represents a specific part of the heart's electrical cycle. The P wave signifies the initial electrical impulse, which starts in a small area called the sinoatrial node, triggering the atria to contract. Following the P wave is the QRS complex, a sharp series of peaks and valleys representing the rapid electrical activity sweeping through the ventricles, causing them to contract. Finally, the T wave marks the ventricles resetting and preparing for the next beat. Each of these components tells a story about your heart's rhythm and health. For example, if the P wave is unusually shaped or missing, it may indicate a problem with the atria. A misshapen QRS complex might suggest an issue with the ventricles, and an abnormal T wave could be a sign of inadequate oxygen supply to the heart muscle. So an ECG provides a snapshot of the heart's electrical activity. But what happens when this activity goes awry? The heart's rhythm is maintained by a sophisticated network of cells, known as the conduction system. This system is the heart's internal electrical wiring that keeps our ticker ticking. It's a bit like a finely tuned orchestra, with each component playing its part in perfect harmony. At the heart of this system is the sinoatrial node, or SA node, the natural pacemaker. It's here in the right atrium where the electrical signals that initiate each heartbeat are generated. These signals then travel down to the atrioventricular node, or AV node, the gatekeeper, which regulates the speed of these signals before they move on to the ventricles. From there, the signals speed down the bundle of His, a highway of fibers that split into the right and left bundle branches, leading the charge to the Purkinje fibers. These spread the electrical signals throughout the ventricles, causing them to contract and pump blood throughout the body. This entire process, when functioning correctly, results in the steady rhythm we know as our heartbeat. But what happens when this orchestra hits a wrong note? Well, that's when we encounter arrhythmias, or irregular heart rhythms. Arrhythmias occur when the electrical signals that coordinate the heart's beats are not working properly. They can cause the heart to beat too fast, too slow, or irregularly. This can be seen on an ECG, or electrocardiogram, a test that measures the electrical activity of the heart. On an ECG, a normal heartbeat will show a consistent pattern of peaks and valleys, representing the different stages of a heartbeat. In contrast, an arrhythmia might show irregular patterns, extra beats, or even missing beats. For example, atrial fibrillation, a common type of arrhythmia, will often appear as a chaotic and irregular pattern on an ECG. Arrhythmias can be worrisome, but understanding them is the first step towards managing them. Armed with this foundational knowledge of the heart's conduction system and what constitutes an arrhythmia, we can better understand our heart health and navigate the path towards maintaining a healthy, steady rhythm. Despite its resilience, the heart is not invincible. Heart disease remains a leading cause of death worldwide. It's a sobering reality, but one we cannot afford to ignore. There are various forms of heart disease that we need to be aware of. First, we have coronary artery disease, also known as CIAD. This occurs when the blood vessels that supply blood to the heart become narrowed or blocked. Imagine a bustling highway suddenly bottlenecked down to a single lane. That's what happens when plaque builds up in the arteries. The heart doesn't get the oxygen-rich blood it needs, and this can lead to chest pain, shortness of breath, or in severe cases, a heart attack. Then there's heart failure, a condition where the heart can't pump blood as well as it should. It's like a tired runner struggling to keep pace. Symptoms might include fatigue, breathlessness, and swelling in the legs, ankles, and feet. Heart failure doesn't mean the heart has stopped working, but it does mean it's not working at its best. Let's also talk about valvular heart disease. Our heart valves act like traffic cops, directing the flow of blood through our heart. But when these valves don't open or close properly, it disrupts this flow. This can result in a variety of symptoms, from fatigue and shortness of breath to irregular heartbeat. Risk factors for heart disease are numerous and diverse. Some, like age and family history, are beyond our control. But others, like smoking, poor diet, lack of physical activity, and uncontrolled high blood pressure or diabetes, are within our power to change. Prevention is key. It's never too early or too late to start taking care of your heart. Regular exercise, a healthy diet, maintaining a healthy weight, not smoking, and controlling cholesterol and blood pressure can all contribute significantly to a healthier heart. Regular checkups and screenings can also help detect any potential issues early. Remember, heart disease doesn't always announce itself with clear symptoms. It's often a silent killer, creeping up without warning. That's why it's so important to be proactive about our heart health. Knowledge is power. The more we understand about our hearts, the better we can protect them. We can't change our genetic predispositions, but we can change our lifestyle choices. And those choices can make a huge difference, not just in our heart health, but in our overall health and quality of life. Heart disease can be frightening, but with knowledge and action, it can be prevented or managed. So, let's arm ourselves with knowledge and take action for the sake of our hearts. After all, they're the one organ that never takes a break, working tirelessly to keep us alive and kicking. Let's return the favor by taking care of them the best we can. To fully appreciate the heart's function, one must understand its intricate structure. The heart is like an exquisitely designed machine, with each part playing a vital role. Here, we delve deeper into the heart's anatomy, exploring its chambers, valves, and major blood vessels. Let's start with the heart's chambers. The heart has 4 chambers, 2 atria at the top and 2 ventricles at the bottom. The atria receive blood while the ventricles pump it out. The right side of the heart receives deoxygenated blood from the body, pumps it to the lungs for oxygenation, while the left side receives oxygenated blood from the lungs and pumps it to the rest of the body. Then we have the valves, the gatekeepers of the heart. They ensure the blood flows in the right direction, preventing any backflow. There are 4 valves: the tricuspid and pulmonary valves on the right, and the mitral and aortic valves on the left. Each valve opens to allow blood flow and then snaps shut to prevent blood from flowing backward. Next, we have the major blood vessels. The largest of these is the aorta, which carries oxygen-rich blood from the left ventricle to the rest of the body. On the other side, the pulmonary artery carries deoxygenated blood from the right ventricle to the lungs. 2 key veins, the superior and inferior vena cava, bring deoxygenated blood back to the heart from the body's upper and lower regions, respectively. Let's not forget about the heart's muscular wall, the myocardium. This muscular layer contracts to pump blood and relaxes to allow the chambers to fill. The myocardium's thickness varies in each chamber, reflecting their roles. The left ventricle, responsible for pumping blood to the entire body, has the thickest myocardium. The heart's anatomy isn't just about structure, it's also about function. For instance, the heart's chambers and valves work together to ensure efficient blood flow. The atria passively fill with blood, then contract, pushing blood into the ventricles. The ventricles then contract, forcing blood out of the heart, while the valves ensure this blood flows in the correct direction. The heart's anatomy also plays a role in its electrical system. Specialized cells in the heart generate and propagate electrical signals that trigger the heart's contractions. These signals start in the sinoatrial node, located in the right atrium, and travel through the heart's muscular walls, triggering coordinated contractions that efficiently pump blood. By now, it's clear that the heart's structure and function are intimately intertwined. The heart's anatomy, its chambers, valves, and blood vessels all work together to ensure it performs its vital role efficiently. Any disruption to this delicate balance, whether structural or functional, can lead to serious health issues. The heart's structure and function are intimately linked, each influencing the other in a delicate balance. The heart, with its steady rhythm and complex structure, is a testament to the wonders of the human body. Let's take a moment to reflect on the fascinating journey we've embarked on, exploring the intricacies of this marvelous organ. From the rhythmic beats that serve as the soundtrack to our existence, to the intricate dance of electrical impulses that control these beats, the heart is nothing short of extraordinary. The ECG, a simple yet profound tool, provides us with a window into this intricate ballet. It maps out the heart's rhythm, revealing the unity and coordination of millions of cells working in harmony. This harmonious rhythm is orchestrated by the heart's conduction system, an electrical network that ensures each beat is timely and precise. But as like any finely tuned machine, things can go awry. Arrhythmias, or irregular heartbeats, disrupt this harmony. They signal a deviation from the norm, a hiccup in the heart's rhythm, which can range from benign to life-threatening. It's a stark reminder that our heart, while resilient, is not invincible. We dove deep into the silent killer, heart disease. It's a lurking threat, often striking without warning, and its impact is devastating. It's not just a disease of the elderly or the unfit. It can affect anyone at any age regardless of lifestyle, but the good news is, with early detection and proactive management, it can be controlled, and in some cases even reversed. Delving into the heart's anatomy, we've seen how it's not just a simple pump but a complex organ with a structure as intricate as its function. Each chamber, each valve, each blood vessel plays a crucial part in ensuring the steady flow of life-giving blood to every corner of our body. So, what are the takeaways from our journey? First, the heart is a marvel of biological engineering. It's a testament to the complexity and ingenuity of the human body. Second, while it's resilient, it's also vulnerable. It can be affected by a variety of conditions, some silent and insidious, others loud and disruptive. And perhaps most importantly, our heart's health is, to a large extent, in our hands. Our lifestyle choices can have a profound impact on its well-being. A balanced diet, regular exercise, stress management, and regular health checkups can go a long way in keeping our heart healthy and strong. In conclusion, understanding the heart is not just a fascinating intellectual pursuit, it's vital to our health and our survival. It's about appreciating the marvel that beats within our chest, about understanding its rhythm, its structure, its vulnerabilities, and its strength. Understanding the heart is not just for doctors or scientists, it's for everyone who has a heart and wants to keep it beating strong.